On August 21st, a once-in-a-lifetime phenomenon will occur in Clarksville, Tennessee. And Austin Peay State University is one of the best places in the world to witness it. The phenomenon is the 2017 eclipse. Join us for one of our Eclipse experiences, 7 p.m. Sunday, August 20th, as we host former astronaut Dr. Ray Seddon for a special presentation in the Dunn Center. On Monday, August 21st, we will host our Eclipse events in the Dunn Center for education and entertainment activities prior to the eclipse. Live viewing opportunities will take place at Forterra Stadium during the eclipse. Keep in mind that you need a pair of certified solar glasses to view this spectacle. For more information or to buy solar viewing glasses and commemorative eclipse books, visit apsu.edu/eclipse.
Hello and welcome to the 91.9 Newsroom. I'm Rebecca Nanny, and today we're going to be talking about the upcoming solar eclipse that's supposed to pass over Clarksville on Monday, August the 21st. Today we'll be hearing from various professors, safety representatives, and a few other people to tell us what to expect during this event. Today, look forward to hearing from the Austin Peay Police Chief, Chief Kazitz, as well as Sandra Brandon, who will be coming to represent the Montgomery County Sheriff's Office. But first, we're going to hear from Dr. Spencer Buckner, an associate professor with the Department of Physics and Astronomy, to discuss the details of the eclipse and the whats and whys of the phenomenon. Thank you for joining us today, Dr. Buckner.
Thank you for having me.
So let's jump right in. Can you tell us what causes an eclipse to occur?
An eclipse occurs when the moon passes directly between the Earth and the sun. Now, the orbit of the moon is tilted a little bit from the orbit of the Earth around the sun, so it doesn't always pass directly between us. We have new moons and full moons every month, but not every month do we have an eclipse. So it's only when the moon is crossing the plane of the Earth's orbit around the sun and it's at a new moon phase that we have a total eclipse.
Okay, that's awesome. I didn't know that the new moon phases affected the eclipses, so
Yep.
That's good to know. Do you know what time we can expect to see this eclipse visible to the people in Clarksville?
Well, the first touch of the sun, or of the moon on the sun, will be just before noon at 11:59 or 11:57 a.m.
Okay.
on August 21st. And then the totality starts at 1:26.
Okay, and what exactly is the totality?
Totality is when the moon is completely in front of the sun. The sun is completely blocked by the moon. And it will get, some people say it's dark as night, but it's not going to be quite that dark. It'll be more like late twilight. Is how dark it will be at 1:30 in the afternoon, basically. So fireflies will come out, crickets will start chirping, all the things, the birds will go back to their nests, all the things you would expect for animals to do when it gets to be sunset and dark.
Perfect.
And then the last touch of the moon leaves at just before 3 o'clock. So the whole thing will last about 3 hours.
Awesome. That's really cool. So to kind of bring it back, do you know what the most famous total eclipse was in history?
Well, there's several of them that had historical importance. There was one back in ancient Greek times that it had been predicted by an astronomer, and there were two of the Greek city-states that were actually at war at the time. And the eclipse came, and they were so startled by it and surprised by it that the war ended. And they went back to their homes, and that was the end of the war. The most famous one in modern history, I guess, was the one of 1919. At that time, Einstein had published his theory of general relativity, and one of the predictions of the theory was that light would be bent by a gravitational field. And the only way to test it would be to see if you can notice a change in the position of stars very close to the sun. And of course, you can't see stars very close to the sun except during a total eclipse.
Yeah.
And so there were expeditions to South America and to an island off the coast of Africa that set up telescopes and did the experiment and actually verified Einstein's general theory of relativity. And that was 1919. It was also geopolitically, it was kind of an important thing because that was right after World War I, and Einstein, of course, was German. And the major part of the expedition was put on by the English, And so it was kind of a post-war cooperation type thing.
Interesting. So with knowing the history of eclipses, can you tell us when we can expect to see the next solar eclipse in North America? Or
The next
from North
solar
America?
eclipse in North America will be on April the 8th in 2024. It will come up out of Mexico, across Texas. I think it clips a little bit of Oklahoma and Arkansas and goes into Missouri, Illinois, Indiana, Ohio, exits out along the Great Lakes into Canada, and then leaves the continent over in Nova Scotia.
So close to us, but not quite like it will
Not
be this
quite
year.
like this one. No, this one is that one is a north-south crossing, and this one is an east-west crossing. This is one that crosses the long width of the continent.
Nice. So are total solar eclipses only visible from Earth, or can, say, the astronauts that are orbiting around us see it as well?
Well, the astronauts, the problem the astronauts are going to have is they're moving so fast. They'll get like maybe half a second or 2 seconds of totality is all they get because they're moving so fast. They get through the shadow very quickly. But eclipses occur anywhere one astronomical body passes in front of the sun. So like for Mars, they have eclipses. They have two very, very small moons on Mars. Their eclipses are very brief because the moons are so small, and I think they're pretty rare as well.
Okay, so they're not as common even though they have two moons?
And then there are, Jupiter has eclipses as well. There are a number of large moons in Jupiter. Of course, you don't have any place to stand on Jupiter because it's a gas giant, but you can see the shadows of the moon through telescopes on Earth. If you look at the planet Jupiter at the right time, you can see a little dark spot moving across the planet that is an eclipse occurring on Jupiter from one of its moons. So eclipses occur whenever a moon or some other object passes between the sun and that object. So they occur on all the planets if you've got a moon.
Okay, and do you know we all probably know the general difference between a lunar and solar eclipse, but can you tell us a little bit more about it?
Well, a lunar eclipse is the Earth passing between the sun and the moon. And so if you're on the moon looking back towards the Earth, you see an eclipse, solar eclipse. The difference is, of course, the moon is much smaller than the Earth, so on the Earth the eclipse shadow is only about 100 miles wide, whereas on the moon it's about 3 times wider than the moon is. And so it completely covers the whole moon. They go into eclipse. And if you're on the Earth looking at it, you'll see the moon get very, very dark. So we'll go from the brightness of a full moon night to almost a night with no moon. So it'll get very dark, and you can see a lot more stars and stuff.
So are lunar eclipses more common than
They
solar
are because
eclipses?
you only have to be on the right side of the planet to see a lunar eclipse. Whereas a solar eclipse, because that path is only about 100 miles wide, you've got to be in the right spot on Earth to see it. So lunar eclipses are a little more frequent, and all you got to do is be on the right side of the planet Earth to be able to see it.
Okay. And while we're talking about differences, while reading up about our total eclipse that's going to come, I was reading about annularity eclipses. Can you tell us a little bit about those?
Annular eclipses, well, the moon orbits the Earth in what's called an ellipse. It's not a circle, it's an ellipse. So at times it's going to be farther away from the Earth, at other times it's closer. And if the moon is farther away from the Earth, of course, it appears smaller from our vantage point. So if it's at its maximum distance from the Earth when the eclipse occurs, the moon's not quite big enough to completely cover the sun. It'll move directly between the Earth and the sun, but you'll still get a ring of sunlight leaking around the edges of the moon because the moon's smaller in appearance than the sun is. So you get an annulus, and so that's why they're called annular eclipses. It's a ring of fire is what we call it. So you get the sun leaking around the edges of the moon like that.
And are those more common than total eclipses?
Not really. They're about as frequent. There was one in 2014 out in the western part of the U.S. I think it ended in West Texas, in the panhandle of Texas somewhere. I was actually out in Arizona at Kitt Peak National Observatory at the time and got to see it. They're interesting. but they're not like a total eclipse. It's kind of the difference between a hamburger and a T-bone steak. You know, which do you really want? You know?
Okay. And I know you were saying that the next one we can expect is in 2024. Can you go into detail about how computers come about predicting that information?
Well, we've been observing the moon for as long as we had the ability of observing, but accurately observing with telescopes and getting positions and so forth for a couple of hundred years, and even more intensely since the Apollo missions. The Apollo missions actually took up instruments that will allow us to very carefully measure the distance between the Earth and the moon to within a couple of centimeters. And so we have a very accurate plot of what the orbit of the moon is, and of course we've got very accurate observations of our orbit around the sun, so it's just a matter of doing very complicated calculations. But there is a website that NASA has. It's called the 5 Millennial Eclipse website, and it has calculations. It will show you maps of where the eclipse is going to occur and when it occurs, and give you all the times and all that kind of stuff for a total of about 5,000 years, going from 3000 AD to 2000 BC, or is it the other way, or maybe 3000 BC to 2000 AD? Well, no, it's got to be 3000 AD, because it's got going out into the future quite a ways.
Well, that's super interesting. And what website was that again?
I don't have the URL with me. It's a NASA website. I wouldn't even want to guess it to you. Just Google 5 Millennial Eclipse page.
All right.
And they'll have it, I'm sure.
Okay, and can you tell us a little bit, how do scientists or astronomers use the information they get from a solar eclipse to benefit them? What value does it have for your research? There
are satellites we have out in space now that look at the sun continuously, and they look in all sorts of different wavelengths, but to see the solar corona, those instruments that are out in space have what's called a coronagraph. It's a small disk they put up right in front of the sun. But the problem is the width of that disk, the apparent width of the disk, is about 2.5 times the width of the sun. And so they block the inner corona. You can't see the inner corona of the sun. The only time you can see it is during a total eclipse, because the moon is just precisely the right size. And so that's one of the experiments we're going to be doing. It's called Citizen Kate. And I don't remember what the CATE stands for, but it's a NASA acronym or something. But the idea is to have identical telescopes set up all along the eclipse path to observe the inner corona of the sun and see what its behavior is. How does it change over the course of the 90 minutes that it will cross the country, the whole country. So that's the biggest scientific thing going on right now, is observing the inner corona of the sun, because there really is no other way to observe that part of the sun. It's just not possible with the satellites that we have.
And does that information help you understand its age, and
it helps us understand how the outer part of the sun seems to work. The corona of the sun is at temperatures of over 1 million degrees. And yet the surface of the sun is only about 6,000 degrees. So how does something that's only 6,000 degrees heat up an area to millions of degrees? It doesn't seem to make sense, and that's one of the big puzzles in solar physics right now, is how does that go on? And we think it has to do with magnetic fields, and of course the corona follows those magnetic fields lines, so it will help us to understand that heating mechanism. How can something that's only 6,000 degrees heat something up to several million degrees? And so that's one of the really important things that we're trying to learn about the behavior of the sun. And of course the corona eventually becomes the solar wind. It just kind of dissipates out into space, and of course when the solar wind hits our planet, we get things like auroras, and you get a lot of static and a lot of noise in the ionosphere. And so that's another experiment. There's a NASA group coming up that will be doing some radio experiments, listening to noise levels in the ionosphere and seeing how that changes during the total eclipse.
That sounds awesome. And the Project Kate, that's a part of the Eclipse lectures and programs that's happening here at Austin Peay. right? Or is it?
We don't have any of
just
the
for the
lectures that
department?
are going to be talking specifically about the Citizen Kate experiment. That's just it's a national experiment that's I'm not sure if it's run through NASA or well, I think it is run through NASA, but it is it's a nationwide experiment.
Okay.
That, like I say, I think there are something like 60 stations set up across the country, from Oregon all the way to South Carolina, looking at it. And of course, since we're very close to the center of the eclipse, there's actually several groups doing it in Tennessee and southern Kentucky.
Okay. Are there any experiments or any projects that, say, amateur astronomers around the city might be able to do while the eclipse is happening?
Well, a lot of people are going to be taking pictures, and NASA, I know, is very interested in getting as many of those pictures as they can. Again, some of it is to look at the inner corona of the sun through different kind of cameras. The Citizen Kate experiment is trying to keep everybody using the same equipment. And of course, not everybody in the public has the same camera and the same setup and everything. So.
Yeah.
Those won't be quite as useful as the Citizen Kate, but I know NASA is very interested in getting images of the sun during totality to see what's going on. And then, of course, a lot of it is just enjoying the eclipse itself. One of the things I hope to have with all the things that I'm going to be doing is, I call it slack jaw time. Just stand there with my mouth open, gazing directly at the sun during totality, and I want a minute or two of that. Just let me enjoy it.
That sounds like a great way to enjoy the eclipse. So to close out this interview, I was just wondering if there was anything that you would like to share, or any information you think we need before the eclipse that maybe I haven't brought up or we haven't already discussed.
Well, I don't know if somebody else will say anything about it. You need these things. These are called eclipse glasses. Actually, the better word for them would be partial eclipse glasses. Most of the time, like I say, the first bite is a little bit before noon, and the last bit of it is just before 3 o'clock. The totality, the time that is actually safe to look at, is only going to be, depending on where you're at in Montgomery County, maybe about 2 minutes, 20 seconds is all. That's the only time you can safely look directly at the sun. Otherwise, you need to be wearing something like this. These are for eye safety, and they block out like 99.9999% of all the light, which makes it safe to look at the sun. Because the enjoyment of the eclipse is seeing that bite getting larger and larger, and more of the sun being covered. But to see it, you need to look at the sun safely. And it's actually kind of difficult to look directly at the sun without some kind of eye protection. Your brain tells you, don't do this, this is burning your eyes, and it's very hard to get over that glare. And so eclipse glasses like these, there's lots of places. I know Austin P has a bunch of them, and we've been selling them at the Clarksville market Saturday mornings every summer, or every Saturday this summer. And so you need eye protection of some kind. Eclipse glasses aren't the only way to do it, but there are other ways. But eclipse glasses are probably the easiest, and they're usually about $2 or something like that. So they're not real expensive, and you can get them not just from Austin P. There's Walmart, Kmart, and Home Depot and other places have them for sale too. So.
Okay, well, thank you so much for your information. We really appreciate you coming in and talking with us today. And we'll be right back soon, where we'll be talking to Dr. Smith about eye protection for the eclipse.
On August 21st, a once-in-a-lifetime phenomenon will occur in Clarksville, Tennessee. And Austin P State University is one of the best places in the world to witness it. The phenomenon is the 2017 eclipse. Join us for one of our P-Clips experiences, 7 p.m. Sunday, August 20th, as we host former astronaut Dr. Ray Seddon for a special presentation in the Dunn Center. On Monday, August 21st, we will host our P-Clips events in the Dunn Center for education and entertainment activities prior to the eclipse. Live viewing opportunities will take place at Forterra Stadium during the eclipse. Keep in mind that you need a pair of certified solar glasses to view this spectacle. For more information or to buy solar viewing glasses and commemorative eclipse books, visit apsu.edu/eclipse.